G'day everyone. So we are from the University of Melbourne under the Student Club Engineers Without Borders. Today we'll be running an engineering workshop and we will be demonstrating and talking about what engineering is and also discuss about what we feel as engineering students. So before we rock and roll, I would love to pay my acknowledgement of country. So we would like to acknowledge and pay our respects to the traditional owners of this country and the custodianship of the elders past, present, and into the future. All right, cool. So a bit of things about us. My name is Yizhou. I am currently doing a master's in civil engineering. So all that is about is infrastructure. So personally, I am a transport engineer. So what that means is I work on a lot of transport management and how to direct traffic and design traffic infrastructure that ensures a efficient and safe transportation. There's obviously many other forms of civil engineering, as you'll later discover. I will now pass it on to my other colleagues to discuss their engineering fields.
Hi, my name's Samantha. I study mechatronic engineering. What that is using electricity and computer code to cause things to move by themselves. So this has a lot of application in things like automation and robotics, which I think is really cool.
And I'm Alex. I'm a civil engineer, so I also study civil engineering, and that means that we work on not just bridges and roads, but also geotechnical engineering and structures as well.
Yeah, lovely. So we are all engineering students who are currently studying. All right, so a brief overview of the timeline. So we're going to quickly talk about who EWB is, and then we'll touch on the design brief. So that would then lead on to the activity of the day, which is the fun part, so stay tuned. And then towards the end, if we have time, we'll go through a pop quiz and then figure out how to stay connected. So, who is EWB? Was anyone paying attention in the first minute of the presentation?
Is it Engineers Without Borders?
Yes, correct. It is indeed Engineers Without Borders. We are a non-for-profit organization that wishes to promote engineering that helps better the living standards of community who might not be as privileged as us. So sitting in the Zoom call today, we have three of us who are able to communicate efficiently while just sitting at home in front of a computer screens. Now, if we went to communities who are a bit more underfunded and who lack a bit of resources, they might not have this availability to these kind of technologies. So as such, we have a vision where we want to create a world where technology will benefit all of us. And these are some of the countries we've been to. So there is Timor-Leste, Vanuatu, Australia, and finally Cambodia. In fact, I had a friend recently who visited Cambodia. She was working on a project where she was helping local farmers to establish a water network going to their village. Previously, they had no access to drinkable water. They had to get up at 4 a.m. in the morning and walk miles from the village to go to the local river and collect drinkable water. Whereas now they have freely accessible water in their village, so they don't actually have to travel so far away from the village to go collect water. So as previously touched on, we are engineers, but what exactly is an engineer? Does anyone have any friends, family, relatives who work as an engineer? Or maybe they themselves know a brother or sister that studies engineering? No? That is all right. That's the point of us being here today. We're going to be walking through what engineering does. So there is a lot of fields, a lot of engineering disciplines out there, as you might have already realized. In essence, we are creators. We are trying to design engineering products that help meet the needs of community. And we have today we'll be discussing 6 particular engineering fields that are semi-common. So looking at the first icon here where my cursor is pointing towards, does anyone know what that sort of engineering might be? Or what they see in this icon first?
Is it a leg?
Yes, it is a leg. But do you know what sort of leg it might be? It is not just a normal leg.
Is it a robotic leg?
You're very close. It is indeed a prosthetic leg. And now the type of engineering that work on them are called a biomedical engineer. So those engineers not only work on prosthetic legs, they also work on surgical equipment, so such as CT scanners or X-ray machines. I have heard how a lot of biomedical engineers are also trying to build robotic arms that can perform the functions that their brain intends for them to do. So then so if they don't have the existing arm anymore, they can just use a robotic arm instead to help perform their daily lives, which is pretty cool. So yeah, moving on to the next sort of engineering, which is in this icon here. Do we know what we're looking at, or do we know what it might mean? Any guesses?
Is it a plane?
It is a plane. Do you know what sort of engineers might work on planes?
Flight engineers.
Flight engineers. You're on the right track. It is actually what we call a mechanical engineer. So those are the sorts of engineer that work on projects that develop vehicles that move. So it doesn't have to be a plane. It could be also a car. Could also be an e-scooter. In particular, anything that moves would often involve a mechanical engineer. So they are integral of building things to improve our way of moving and mobility. Very cool stuff indeed. Now, moving on to the next sort of engineering, what do we see in this icon and what do you think it means? Any guesses?
Is it a lightning bolt?
It is a lightning bolt, but what sort of engineers do you think relates to a lightning bolt?
Lightning engineer?
A lightning engineer? It's a good guess, but I think the correct answer is the electrical engineer. So those are the sorts of engineers that work on providing electricity, designing circuits. So I assume some of you guys probably were either being driven to school by your parents, or you might have taken public transportations. And when you're on the road, you might see a lot of traffic lights. Now, those traffic lights were designed by electrical engineers who needed to work on the circuits to make sure that the lights were emitting the right color at the right designated time. And on top of that, electrical engineers also work on building power grids so that everyone can actually, we have lights, we have access to internet, and we can use our own electrical devices. Yeah, so a lot of good stuff that improves our life. Moving on to the next one here, does anyone know what this icon might represent?
Is it a bridge?
Yes, a bridge. We have two engineers that might work on these kind of things inside this room today. Does anyone know who they might be?
A builder?
Builder, yes, a builder might work on a bridge, but normally they work with a civil engineer who helps design the bridges. So civil engineering, as we previously discussed, is very broad. They build bridges, they can build skyscrapers, they design transport network, which is something I'm personally involved in. Alex, who is also a civil engineer, also helps, they build roads, and also they build a networking system to help improve the road connectivity. So basically infrastructure that improves our daily lives in essence. So cool stuff. Moving on to the next one here. Does anyone know what this might represent? We have one.
A robot?
Today. A robot? Yes, it is indeed a robot. Do you know what sort of engineers might work on a robot?
It's the type that she is.
It is indeed a mechatronic engineer. So those are the type of engineers that work on robots and mechanical arms. I'll let Samantha describe in more detail of what it is about.
So as I mentioned earlier, mechatronic engineers look at how computer code and electricity cause things to move on their own. So it has a lot of focus on automation in making things move without telling them to. So in a lot of factories, a lot of machines will create a lot of products that we sell, and it will do that automatically. It will just keep on producing products, even without humans there to tell it what to do. And if you've ever seen any robots before, there is some work with robotic waiters at the moment. And all of that sort of thing is done by a mechatronic engineer, as well as things like amusement park rides.
Very cool. A lot of emphasis on automation. Moving on to the next one here. What do we see inside this icon, and what do we think it might mean?
Is that science?
Science? Yes, it is a science, but does anyone know what sort of science this might be? Is it physics? Is it biology? Can it be chemistry?
Yeah, that one.
That one? Indeed, it is a chemical engineer. So those are the sorts of engineer that work on food flavoring and providing water that is drinkable. So we don't have a chemical engineer in today, but I'm sure they work on a lot of cool stuff that help improve our daily lives. All right, so a lot of engineering that we've discussed about are contemporary engineer solutions or engineer disciplines. But to discuss in further detail, we can't ignore the efforts made by the First Nations engineer, who have also discovered many sorts of their own of engineering applications that have helped them to adapt into the diverse landscapes of Australia. Today we'll be presenting 4 of them, and 2 of which are pretty iconic. One of which is the first one, so we'll be shouting out as a group in 3, 2, 1.
Boomerang.
Yes, well done. All right, the next one here, I might get some hands up. Does anyone know what this is?
Is it a fish catcher?
Yes, it is a fish catcher. It is also known to be a eel trap. So you put that in the downstream, and you'll be able to let the eel swim into the net, so that way you can catch your prey. So very interesting discovery. The next one here, does anyone know what this might be? In fact, I think it is quite iconic, so we might shout it out as a class again. So 3, 2, 1.
Didgeridoo.
Yes, well done, guys. So obviously a very iconic piece of Indigenous instrument. You see it a lot at a lot of First Nations gathering and ceremonial purposes. Cool. Moving on to the next one here. I'll get some hands up. So does anyone know what this might be?
Is it a nail?
A nail? You're close, but maybe give it another try. What do you think it might be?
A sword?
Yeah, you're on track. It is a sword. It is a type. It is sort of a weapon, in a sense.
Spear.
A spear? You're close. It is actually what we call a spear thrower. So essentially this functions as a tube. So you put the spear inside the tube, and the thrower provides you more leverage, so you're able to throw the spear even further away, so that way you can catch your prey that is further away from you with more precision. So yes, indeed, our First Nations people have made some very cool inventions with using engineering discipline and applications. Now I'll be passing on to Samantha to discuss about sustainable development.
So when we design different technologies as engineers, we need to consider something called sustainable development. Has anybody here ever heard that term before, or sustainability? Does anybody have any ideas what it might mean? Yeah, Alex?
Is it like planting trees?
Yeah, exactly. It's like planting trees, or things like composting or riding a bike. These are all actions that make there more materials to use in the future. So when we talk about sustainable development, we're talking about developing technology that doesn't remove all the materials that we can use in the future. So we don't want to use everything today, but make sure that, future generations are still also able to build technology. As engineers, we also need to consider what technology is appropriate. This means that it's going to give a positive impact to the community who's going to be using this technology, both currently and also as we move into the future. So there are 6 main icons that we're going to consider with relation to appropriate technology. Does anybody know what's in that first icon at the top left?
Money.
Yeah, exactly. It's money. As engineers, we need to consider how much different things cost. We work within a set budget, and we need to make sure that we're not exceeding that budget, but we also need to make sure that the people who use our technology can afford to buy it and keep on using it. What about the next image? Does anybody know what that is?
A tree.
Exactly, we've got a tree. Where might we find a tree?
Forest?
Yep, the forest, absolutely. Where else?
In a park.
In a park, absolutely. So these are all examples of what we call our physical environment. So that's the location that we're going to be building technology. So we plant trees in locations that trees will grow, and in a similar way, we want to make sure that our technology is being used in a location where it's actually useful. What about the next image? Does anybody know what that might demonstrate?
It's a charger.
It is a charger. Chargers are commonly used for electricity, and we need to consider the same thing. We need to consider what materials and what electricity is available. So we use our chargers to charge our phone, but if we're at somewhere with no electricity, well then our phone's going to die really fast, isn't it? So when we design technology, we need to think about what electricity and what materials we have so that the technology can continuously be used. What about our next image? Does anybody know what's in that image?
It's a brain.
Yeah, exactly. It's a brain. And what might we have in our brain?
Thoughts?
Thoughts, absolutely. We can also consider this to be our knowledge. So this is making sure that both the engineers who are building technology know what they're doing, but also after the engineers have gone, does the community know how to keep on using that technology? My favorite example is when Tesla cars update, they shut down everything, including the automatic doors, and people couldn't work out how to open their doors because they couldn't find the handles. So we need to make sure that the technology we build is easy to be used by the people who are going to use it and that they don't need excessive amounts of knowledge. What about our next image? Does anybody know what that one might be?
Is that a screwdriver?
Yeah, absolutely. A screwdriver and some tools. What might we use these for once we've already got our technology, once it's already been built? We might use these to make sure that we can fix it, otherwise known as maintenance. So if I build something like a prosthetic leg and it breaks down tomorrow, well, that's not going to be very useful to the person who wants to use it. So we want to make sure that the technologies we build can be maintained and that the people using the technology know how to maintain it. And then our last image, does anybody know what's in this image?
People.
Absolutely, we've got people. So if I were to build a massive 6-lane highway, or more accurately, one of the civil engineers in the call were to build a 6-lane highway right through the middle of your playground, who's going to be happy about that? Nobody's going to be happy. So we've got to make sure that we consider the people who we're building technology for, the people and the culture. And we need to make sure that the technology is appropriate for them. I'm now going to pass on to my next associate who will go through the design brief for today.